A relation is a set of points. So said another way, it's basically a graph, something that we can put in the xy plane. The domain is the set of x values, and the range is the set of y values. Let's make some sense of these definitions by looking at the relations a and b. Notice that a and b are just a set of points, so they're definitely relations. In example 1, I'm going to graph the relation a as well as b. All right, so for a, I'll do that one in blue. Okay, the point -2, 3 is here, -1, 5, 0, -2, 2, 2, and 4, 3. I just plotted this relation, and it is in fact just a graph. I can do the same thing for the relation b. Okay, so b is -3, 3, 1, 4, 2, -1, 1, 2, 3, -4, and 5, 0. So there we go. We have the graphs for relations a and b. To determine the domain and range, I'm going to start with the graph for a. The domain is the set of all the x values. And since it is a set, I'm going to use set notation, and I'm going to let the letter D represent its domain. All we have to do is look at the points and figure out for each of them what's the corresponding x value. I'll start with this point here and I'll work my way right. So this was the point -2, 3. To figure out its x value, you can look down to the x-axis and I get -2. This means -2 is in the domain of A. So I'll just put that here, -2. I'm going to do that for the remaining points. So we took care of this one. Let's now look here. This was the point -1, 5. To figure out its x value, I look down to the x-axis and I get -1. Not a surprise. Okay, here is another point. Its x value is 0. So that means 0 is in the domain. Here I have the point, it was 2, 2, and if I look down to the x-axis, I do in fact see that 2 is the x value. And for this final point here, its corresponding x value is 4. And this represents the domain of the relation A. Now, it's probably no surprise, right? -2, -1, 0, 2, and 4. If you look up at the relation A, these are simply just the first coordinates of every single point. So I know we did this right. But, we're just working with the definitions here. Let's do the same thing, but now for the range. The range is the set of all y values. So we're going to do the same thing where we're going to take all of these points and figure out what the corresponding y values for them are. You can start with any point that you'd like. I'll choose this one here. The y value for this point is 5, so that means 5 is in the range. I guess I'll go down to this point next. Its y value is 3. This also has a y value of 3, but I just want to record it once, so that's all I need. 3 is definitely in the range of this relation. Okay, so I've taken care of these 2 points. I'll go here. The y value of this point is 2. There's only one other point to work with here. This one actually is directly on the y-axis at -2, and that means this is the last value that's in the range. 5, 3, 2, -2. And again, looking back at this list of points, not a surprise. 5, 3, 2, and -2. We don't have any other y value. Let's do the same thing for b, but just go through it a little bit more quickly. So again, I want to find the domain and range for this relation. So let's see. I'll start with this point here. I get -3. I'll go to this point. At this point, both have the same x value, which is 1. Okay, moving on to this point here. Its x value is 2. Here, this point has an x value of 3. And this last one, it's directly on the x-axis at 5. So there is the domain of this relation, B. We could do the same thing for the y values. Last time I worked from top down. Here you could go from the bottom up. I don't think it's going to really make a difference, but let's see. For the range, if I start with this point, I get -4. If I move to this point next, I get -1. If I use this point, I get 0. This point is 2. This point is 3. And this last point is 4. There we go. We have the domain and the range for this relation. And again, it should match up with the points that we have up here. And again, this example is just to go over the basic definitions for a relation, the domain, and the range. For example 2, I want to introduce a very important definition for this class, and that is something called a function. So a function is a relation. So like in the last example, we looked at A and B, which were relations. I just copied them over. But a function is a very particular relation. It has this extra condition. Each x value relates to exactly one y value. So here in example 2, one of these relations is a function and the other is not. I'm going to start with A. So we have these points here. What I'm going to do is mark on the x-axis their corresponding x values. All right. For this very first point here, this has an x value of -2, and -2 relates to just this one spot. This is another way of saying it relates to exactly one y value. So far so good. The x value at -2 related to the y value of 3, and it never happened again. So far, like I said, good. But this has to happen for every single point. All right, so this x value here, it relates to the y value of 5, but that's it. It doesn't relate to any other value. So again, it meets the criteria of the definition of function. Moving on to 0, this relates to just -2, no problem. Here at 2, this relates to 2, no issues there. And then the x value of 4 relates to 3 and nothing else. So what we did is we checked every single x value and it related to exactly one y value. So this means A is a function. Perfect. Now that means something has to go wrong in B. So what I'm going to do is I'm going to mark all of the corresponding x values and see how many y values they relate to. So starting with this one here, it only relates to this one spot, so no problem. All right, but now we just have an issue. Here at 1, it relates to 2, but it again relates to 4, and we can immediately stop at this point. B is not a function. The second that you have one point directly above another, the relation fails this definition. We have an x value of 1 that related to both 2 and 4. I'll write that off to the side. We had x equals 1. It went to both y is equal to 2 and y is equal to 4. If this happens even just once, it means your graph is not a function. It's a relation. We can talk about its domain and range, but it is not a function. And for example 3, here we have a relation because it's a graph. I'd like to figure out its domain and range, and also if this thing is or is not a function. So this is going to be a little more interesting because now we have infinitely many points as opposed to just like a finite list. What I'm going to do is start by focusing on what's the domain and then what's the range. If I look at this graph carefully, there's infinitely many points, but they all have corresponding x values. So if I start right here, like the graph doesn't exist going in this direction, it's like this is my starting point. The corresponding x value here is -4. I'm actually going to mark that on the axis. So the graph begins right here. Now, as I travel along the graph in this direction, what x values do I get back? As you move here, you get these corresponding x values. The reason is, if you pick this point and you look down to the x-axis, you get all of those points back. This means as I move along the graph, the domain, the x values go from here all the way over until we get to here, 5. So 5 is like where it ends. Now there's this open circle at x is equal to 5. That means we're not including this point. You get everything that goes up to this point, but it just does not include this. For this reason, we're going to use interval notation in our answer. Here's the domain of the function. It's all the x values that start at 4, -4, end at 5. They include -4, it just does not include 5. So that's all of these x values. That is where this graph starts and stops, and we get everything in between. Now let's use this same idea for the y values. So if I look at this graph from the perspective of the y values, it's now how far down or up does the graph go? So if I think of this as my starting point, its y value is here at 0. So I'm going to mark that on the graph. So like this is the lowest y value. Now the largest y value as I move up the graph is here. Like you don't get anything that goes any higher than 5. So in terms of our range, it's everything trapped between 0 and 5. So we're starting at 0, we're ending at 5. The only real question that remains is, do I include these values or do I not include these values? We do include 0 because, well, I actually have this point here. It means that 0 is actually a value in the domain. So I'll put a bracket there. Now this could get a little confusing, but as we move up the graph, we definitely stop at 5. Now there's this open circle here, so you might think like, oh, I don't want to include 5. Maybe I'll put a parenthesis here. But the fact that it's not included here doesn't matter because it is included for all these other points. You get 5 as a y value infinitely many times, so it doesn't matter if you throw this one away, you still get it back for these points here. So for this reason, we do include 5 as well. So here's the domain and range. The domain is how far left and right do you go, and the range is how far up or down do you go. The last thing would be, what is this thing a function? So to figure this out, we just want to make sure that every single x value goes to exactly one y value. So the answer to this question is yes, this is a function. And the reason is, any spot that you pick in the domain of the function, if you look up to the graph, you only ever get one point. Like here, I get this one spot. Here, I get this one spot. You don't ever get a point and then a second one. So for this reason, this graph is a function.